Hello everyone, my name is Himanshu Patil and my roll number is H49. Today I am here with my teammates to give a short presentation on the topic Polar Satellite Launch Vehicle. First of all, let's gather some information about the polar satellite and polar orbit. Polar satellite is a satellite that revolves in an orbit which is perpendicular to the equator of the Earth. In simple words, its orbit passes through the North Pole as well as the South Pole of the Earth. Polar orbits are often used for the satellites which do Earth mapping, observation, and navigation, as well as it is used to keep an eye on the weather in various regions of the world. In this presentation, we are going to see the history of the polar satellite, how it was built till the recent launches of it, its variations, its design, and its stages in which it launches a satellite in the polar orbit. The Polar Satellite Launch Vehicle is a third generation expandable medium lift launch vehicle designed, manufactured, and operated by the Indian Space Research Organization. Some notable payloads of the launch vehicle are Chandrayaan 1, MOM, and Astrosat. It has launched around about 319 international satellites from 33 various countries. It has also launched 104 satellites in the Sun synchronous orbit.
My name is Srushti Rawal and my roll number is H59. Let's see history of the PSLV. PSLV launched a total of 62 satellites, from which 27 were Indian and 35 were foreign, including RioSat 2, XSat and etc. The research and development of PSLV began in 1990 at Vikram Sarabhai Space Center in Kerala. With the launch of Bhaskara 1, PSLV was upgraded with 1000 kg payload in 900 km sun synchronous orbit. It has also used in Chandrayaan 1 mission. The prominent launches include LEO, Chandrayaan and Mars orbiter mission, which is also known as Mangalyaan project. The first successful launch of PSLV was in October 1994. Let's see variations of PSLV. There are 5 variants. Let's see one by one. First, PSLV-G. PSLV-G had 4 stages. It had capability to launch 1678 kg to 622 km into SSO. PSLV-CA means Core Alone model premiered on 23 April 2007. It has capability to launch 1100 kg to 622 km SSO. PSLV XL was the most upgraded PSLV. The first use of PSLV XL was in the Chandrayaan 1 by PSLV C11. The capacity of PSLV XL is 1800 kg to SSO. Let's see PSLV DL. PSLV DL variant has only 2 strap-on boosters with the 12 tons propellant on the load. PSLV C44 on the 24 January 2019 was the first flight of the PSLV DL. PSLV QL has 4 ground-lit strap-on boosters, each with 12 tons of propellant. PSLV C45 on 1st April 2019 was the first flight of the PSLV QL. As you can see in the table, there were 50 launches by the PSLV, in which 47 were completely successful, 2 were gone through failures, and 1 was partially failure. Here we see the variations of PSLV.
Hello friends, my name is Shubham Suryavanshi and my roll number is H70. Now I am going to explain the design of the PSLV rocket. The PSLV rocket has height of 46 meter long and it has a diameter around 2.8 meter. That is, we can say its width is as similar as the small regular shape room. it has an internal guidance system. The internal guidance system is a basically electronic system that monitors the speed, velocity, acceleration of the missile. It is also helpful for the navigation to the missile, and we can operate the whole missile through base operating station due to internal guidance system. Next point is pitch and yaw achieved by the interposing aqueous solution of strontium perchlorate in the nozzle to the established SITVC. Let me tell you the pitch and yaw. These are the nozzle moment of the missile. The moment and deflection of due to the missile is called as gambling, and the pitch is the up and down motion due to the nose, and whereas the yaw is the deflection of the nozzle about a vertical axis. And SITVC stands for secondary injection thrust vector control. And next point is two cylindrical aluminum tanks are attached to the solid rocket boosters for the boosting of the stages of the rocket and storing the injected fuel. And roll control thruster, as I said before, the pitch and yaw are the roll motion controls. Here is an exploded view of the vehicle. As we know that the PSLV is a 4-stage rocket. You can see the 4 stages in the slide, and I want to tell one more thing, that as it has 4 stages, as like that it also has 4 types, that is GTO, which is called as geostationary transfer orbit, sub GTO, sub geostationary transfer orbit, SSO, sun synchronous orbit, and LEO, that is low earth orbit. And you can see the first stages of the 4 liquid straps and vented interstage and solid motor. After that, GS to liquid stage, interstage. After that, equipment bay, payload adapter, GS3 cryo stage, and last is the satellite, which is situated in the nozzle of the vehicle, and payload fairing. I want to tell you the what is the payload. Payloads mean the how much amount of weight and a vehicle can take. This means by payload, and here is the 418 ton of payload a PSLV can take. Thank you.
Thank you, Shubham. Hi guys, I am Shourya Bhosale. I am going to explain you the stages of PSLV. There are actually 4 stages of separation to launch PSLV rocket. The first stage consists of 6 strap boosters, 139T hydroxy terminated polybutadiene. First 4 activated during the liftoff, and the remaining 2 at 2.6 km altitude. This completes with the first stage, and second stage is ignited. In second stage, it is powered by single Vikas engine, contains 41.5 T propellant, unsymmetrical dimethyl hydrazine, generates maximum thrust of 800 kilonewtons. This completes with the second stage, and third stage is ignited. In the third stage, 70 of hydroxyl terminated polybutadiene produces maximum thrust of 240 kilonewton. Fourth stage, powered by generatively cooled twin engine, carries up to 2500 kg of propellant fuel used in monomethyl hydrazine. Thank you. This ends with the stages of PSLV launch. Thank you.
Hello everyone, my name is Aadesh gaikwad and my roll number is H18. So move towards forward. Satellite launching methods are as follows. Firstly, the polar satellite, in which it launches the vehicle in space with help of rocket. It is taken up from the stations in India we have stations in Sriharikota, Chennai. So after that, we can say that it is first step of launching the satellite. So next stage occurs in space, where the separation of the rocket is to be occurred. So basically, rocket have 3 stages of fuel, in which they are totally separated after the use, and it is totally vanished in the earth atmosphere and totally burned down finally. So within the time the rocket of first rocket, it reaches towards in a space. After that, satellite reaching in space, we can say that it is last stage of polar satellite launching vehicle system in its orbit. So after launching the satellite in its orbit, last stage remains alive. So what is last stage? Last stage is instead of becoming debris, last stage remain active for at least 6 months. So we can say that uh, uh, the last stage of rocket is to be alive for at least 6 months. So we are discuss about the how satellite launches in space. So moving towards forward, can you know about Indian navigation satellite system? So basically it is an operational type of navig system, and it is an autonomous regional navigation systems in which they provide accurate and real time. So IRNSS, that is Indian Regional Navigation Satellite System. It joins the constellations for several navigation system is to be provided there. Basically it is includes 7 types of systems. It is independent regional navigation systems in which the satellites are spread all over the space through the regional stations. Though it has lots of benefits, it is useful for shipping, for transport purpose, for railways, in resource management, in location based services, and for navigation also. And as we know, there are lots of uses of operational name, that is navigation satellite system, and it have lots of benefits too.
Hi, my name is Shubham Raut. My roll number is H58. So I come up with the slide that name is Resources at 2. It follows the mission Resources at 1 because and it is very important for us and our Indian Institute, that is Indian Space Research Organization. This is a governmental organization. So resources at 2 has very significance and importance because it launches the 18th remote sensing satellite built by the ISRO. Also it intended to continue remote sensing data services to global users. So it has different various softwares greater than the resources at 1, and carries 3 cameras which are similar to those on the resources at 1. As I said, this is follows by the resources at 1, so it is the modification of resources at 1, that is resources at 2. Also it carries the additional payload as an automatic identification system from Canada Space Organization. So these are the different significance and information about the resources at 2 uh, as we see here. So come to the next slide. Here we can see the different launch vehicles which are developed by the ISRO. So there are we mentioned here the 5 main type of launch vehicle, that is SLV, ASLV, PSLV, JSLV, and other type of JSLV also. So first is the we see here the first type is SLV, that means satellite launch vehicle. So it is the firstly developed by the ISRO from our freedom. So it has height 22.7 meter, lift of weight 17 ton, propulsion all solids, fuels are consumed in this kind of rocket. The payload capacity is 40 kg, orbit low earth orbits. So next one is augmented satellite launch vehicle. As we differentiate between SLV and ASLV, we can observe there are two advanced boosters are connected with it. So it has also the height 23.5 meter, lift of weight 13 ton, propulsions all solids, payload capacity 150 kg, and also the orbit is same as SLV, that is low earth orbit. So come to the next, that is the PSLV, and which is important for our the aspects. it's included. So PSLV means the Polar Satellite Launch Vehicle. This kind of satellites are used for the launching the satellites in the polar region, that means north and south pole of the earth. So this kind of satellites rotates from the north pole to south pole and again from south pole to north. So these kind of satellite launch vehicles used to uh, launch the satellites to the polar region. So next is GSLV Mk2 and GSLV Mk3. So it has the specification as heights are different because they are modified from the PSLV. So height is 49 meter, lift of weight 414 ton, propulsions, that means the fuel consume capacity and the fuel type, that is solid, liquid and cryogenic fuels are used for this kind of satellite launch vehicles. So payload capacity of the boats are different from their functions. So as I said, these are GSLV, that means the geostationary satellite launch vehicles. So they launch the satellite in the geostationary orbit of the earth, and this kind of satellites rotate around the earth and completes its one rotation within 24 hours. So these are the geostationary satellites. So in this report, we come across the different information related with the ISRO and the Space Research Organization.